welcome to this course once again. Now we are going to start one new topic under this course, which is human centered design. So, as it's the topic itself is suggesting that we have to take care of the human aspects and we have to put human in as a center while performing the designing. So, whether it be a designing of any product or any system, so we have to take care of the user population. So, we have to first specify the user population and then design to accommodate as wide a range as possible. So, normally we take care of the 90% of the users while specifying any design. So, in that user population, the word population is used in a statistical sense. So, and it refers to the group of people sharing something, something common in terms of job, something common in terms of their ancestors, something common in terms of occupations, geographical locations, age group and ethnicity, so on and so forth. So, in that context we will be inclining towards our topic towards human centered design, and in that context we will be covering the introductory part, and then a new term that we will be discussing, that is anthropometric data and analysis, design principles, human centered design principles, human centered automation, and some sort of fitting person to the job and fitting job to the person of the basic we have covered in the previous lecture. So, now as far as the introduction goes, what are the challenges and solutions, possible solutions of a human oriented design. So, the question that comes in mind, that what is meant by when we hear a product is ergonomically designed. So, an ergonomically designed product should be focused to the 90% of the users. In fact, that population, user population, it refers to the group of similar people. As I have mentioned that it may the group may be of similar age group, languages, or whatever is the problem statement towards designing a particular thing. So, in that context that population is referring to, and similarity may be in users job, age group, ethnicity, geographical location, so on and so forth. So, approach of ergonomics is to consider product dimensions in human terms in view of the constraint placed on their design to body size variability. So, we need to understand what is this human variability and what are their sources. So, in that context, body size and proportion vary greatly between different population. So, because US citizen will be different from the Asian citizen. So, in terms of its height, in terms of its all the aspects, so we have to take care of this human variability also, because of this human variability, anthropometric study in the product or system design comes into picture. So, we need to learn that what are the sources of human variability. So, in that context, body size and proportion vary greatly between different populations. Size variation is also due to overall natural growth of human being on the passage of time. Human also vary due to genetic differences, and human vary due to climatic conditions also. Human vary due to better living conditions also. So, designer has to analyze in what ways anthropometric mismatches might occur and decide which anthropometric data might be appropriate to the problem. So, now we will try to learn what this anthropometry world is all about, and what are those anthropometric mismatches and anthropometric data that we have talked about in this previous sentence. So, we are starting this particular anthropometric explanation. So, anthropometry is again a Greek word is a combination of two Greek words basically. So, first is anthropometry, anthropo, and second is metron. So, it means the measurement of human being. So, that is the definition of this anthropometry, and it is basically defined as an empirical science concerned with the physical measurements of a human body such as height, range of joint movements and weight. So, as I have stated that it is derived from the Greek words anthropos and metron, and it is usually considered as a branch of anthropology. So, it strength characteristics also sometimes included in the scope of anthropometry. So, as far as anthropometric variables and data is concerned, considerable amount of anthropometric data has been collected and published over the years. So, despite the significant expense in finding statistically representative subjects from the population, performing the measurement and compiling the data. So, as per the anthropometric data, so there are two types of dimensions we use to measure. First is static dimensions and second is dynamic dimensions. So, static dimensions are those measurements which has been taken in a fixed position, like if you are sitting and standing condition. So, there are various selected anthropometric variables and methods of measurement as well. So, those anthropometric variables are when you stand still and you measure your stature, that is height. So, the standing height is your anthropometric variable. Eye height is the vertical distance between floor and inner eye corner with the subject standing in the preceding. The shoulder height, elbow height, sitting eye height, sitting shoulder height, shoulder breadth. So, this is the horizontal distance between right and left outer upper points of the shoulder blades. Knee height, your vertical distance between floor and upper surface, and basically this knee height is the vertical distance between floor and upper surface of the thigh with knees bent 90 degrees. Hand length, foot length, head length, and forward reach is the maximum distance between a vertical wall against which subject presses shoulder blades and grip axis of hand. Your body weight, which subject standing still on weighing scale. So, these are the anthropometric variables through which we predict the information about a particular person and a group of person. So, there are before going to have some various posturing conditions, let us have a brief look over the human variability. So, differences in the body dimensions exist among people because of ethnicity and nationality, heredity, diet, health, sex, age and living conditions. So, now as shown in this slide, there are two persons. First is in standing condition and the right one is in the seated condition. So, the possible static dimensions of several anthropometric variables are as follows. So, these are, as you can see from this particular figure, that head length is from the wall to this point, and stature height is the total height, like vertical distance between the floor and the highest part of the head with the subject standing erect. So, the erection is important in order to have complete height of a particular body. So, in the same way, the eye height is often measured as a vertical distance between floor, inner eye corner, that is the inner eye corner, and with subject standing as in the preceding. So, shoulder height is measured as a vertical distance between the floor and outer upper point of the shoulder blade with the subject standing as in the preceding. In fact, as the elbow height that has been measured here, elbow height is defined as the vertical distance between the floor and the lowest bony point of the elbow, bony point, this is the bony point, this one is the bony point of the elbow with the upper arm hanging freely, with the upper arm hanging freely and elbow fixed at 90 degrees with the, this is the 90 degree. So, in this way the possible anthropometric variable dimensions has been measured, and when you talk about the seating condition, there are various heights that has been involved in predicting the several information, and which is helpful in the design of any product, let us say designing of a chair. So, is the how we can define and how you can measure that particular sitting height, set sitting erect, and that is vertical distance between horizontal sitting surface and the highest part of the head. So, this is the highest part of the head and this is the floor. So, distance between the floor and the highest part of the head is known as sitting height. In the similar way, sitting eye height is defined, it is the vertical distance between horizontal sitting surface and the inner eye corner with subject sitting in the proceeding. In the similar way, sitting shoulder height is defined. So, sitting shoulder height is defined as the vertical distance between horizontal sitting surface and the outer upper point of the shoulder blade. Knee height, another thing is knee height, which is a major concern. So, knee height is again we can determine with the help of measuring the vertical distance between the floor and the upper surface of the thigh, with knees bent as a 90 degree. So, these are the possible static dimensions of the human body. So, there is again another posture. This A is the standing and the standing conditions, and this is the full arm condition. The B is the full arm condition, in which one scaling techniques has been utilized. So, this scaling technique is utilized in order to have any measurement based product, like if you are designing, let us say if you are designing a cloth. So, for designing a cloth, you should know completely the proportion of your hand with respect to the total height. So, now as you can see from this figure A and figure B. So, in the figure B, this particular ratios have been defined as 0.224 sh, 0.19 sh with respect to the stature height. So, sh is the stature height. So, this particular scaling technique is used when designing for users where or whose anthropometry is unknown. So, for example, a group of workers know to differ from the general population for some reason. So, for those, scaling technique is helpful in evaluating the dimensions for designing a product. So, this is a most general condition where this every height and every length you can say is predicted on the basis of this particular with respect to this stature height. So, the linear body dimensions expressed as a percentage of stature. So, all the linear body dimensions expressed as percentage of stature. Now, we come to the types of anthropometric data used in ergonomics. So, there are basically three types of data. First is structural data, second is functional data, third is Newtonian data. So, the structural data in that structural data measurement of a body dimension of subject in static postures. So, that is typically used in to optimize furniture. So, example of this structural data is utilized in furniture, clothes and vehicle cab dimensions, etc. As far as functional data is concerned, so it is collected from subjects who are allowed to move one or more limbs in one or more planes with respect to a fixed point. So, shape of 3D surface swept by moving the arm with the elbows extended or the amount of forward reach when the subject can bend at the tip, bend at the hip. So, in this way that where the generation of workspace envelopes whose size increase with the number of joints allowed to move. So, here that kind of data is known as functional data. So, as far as Newtonian data is concerned, so it included both body segments, mass data, data about the forces and that can be exerted in different tasks. So, so all sort of analysis aspect in which the calculation has been carried out in terms of force analysis. So, those things comes in the Newtonian data. Another example or in fact another thing that is we can take it as a different segments of measurements here. So, here we can see that a person who is sitting, possible measurements we can take as a seated height, eye height, shoulder width, knee height, C width, and we have also as well as in the front we have to take care of these aspects while designing, let us say designing a chair. And second thing is we also have to take care how much reach of a particular person has, and about this upper arm liberty, lower arm liberty, upper leg, seat height and seat length. So, the measurements taken on the human body with the subjects in rigid standardized position. So, they are typically length, width, height, circumference. These measurements include standing height, seated eye height, upper length, knee height, seat length, upper and lower arm length, reach, shoulder width, tip or seat width, etc. So, suppose if you are sitting inside a car in the driving seat, so those aspects are very much important in order to design a proper workspace in order to handle the steering wheel inside and if a person is sitting. So, that reach is also very important. Again what are the other possible measurements that we take into consideration while capturing the anthropometric data. So, those data you can visualize with the help of this whole figure which I have taken from one book R.S. Bridger. So, that is the first kind of thing is weight, second is stature. Stature is nothing but the standing height that is represented here as a 2, and it is expressed as a vertical distance between the floor and highest part of the head with subject standing erect. So, he is standing erect. So, in that situation whatever the measurement is taking place, it is known as stature. Third is eye height. Eye height is again it is a vertical distance between the floor and the inner eye corner. Shoulder height is this number 4. So, shoulder height is vertical distance between floor and outer upper point. Basically, this is the outer upper point of the shoulder blade. Again, fifth is elbow. So, elbow height is again the vertical distance between the floor and the lowest bony point. Again, this is the waist height. So 6 is the waist height. So waist height is this, 6 1 is the waist height, where from the where the waist is starting and that distance to the floor. 7 is the knuckle height. Again this is the portion from where we have to measure the knuckle height, and this is the knuckle height. 8 fingertip height. So 8 to 1 is the fingertip. So from the point where this particular finger is ending, that particular point is considering as a measurement point to the floor itself. So this point is the fingertip point. Touch yourself, so the possible length over which your arm can be stretched is known as arm span. So ninth, this particular distance in a stretchable condition is total, is giving you arm span. 10th is elbow height, elbow span. 10th is elbow span, means if you are stretching while stretching only this portion, and while confining the this portion in a squeezed way. So this particular height is known as, this particular length is known as elbow span. 11 vertical grip reach. 11 is the vertical grip reach. So in a vertical condition, if you are stretching your hand, and the vertical and the topmost point up to which your vertical hand, your hand can be stretched out, so that from that point to the floor is known as vertical grip reach. In the similar way, the forward grip reach is also defined. You stretch your hand in a forward direction and you measure the distance from where your hand is originating, initiating to the extreme point through up to which your grip can be reached. So that particular extension is known as forward grip reach. The 13th point is forward fingertip reach, that you can see here as a forward fingertip reach. Here you, as a forward fingertip reach, this is particular how you have to stretch your fingers here. In the 12th case, you do not have to stretch your fingers. Here you have to stretch your fingers, and the extreme point, from the extreme point to the initiation of your hand, that we have discussed weight, stature, eye height, shoulder height, elbow height, waist height, knuckle height, fingertip height, arm span, elbow span, vertical grip reach. So we will describe about the vertical grip reach. In fact, this 11 point is the vertical grip reach. So this vertical distance from let us say vertical distance from the floor itself to the extension to the topmost point of at the stretching condition of your hand. So this particular point to this point is known as a vertical grip reach as far as forward grip reach is concerned. So if you are not extending your fingers, only extending your hand, so up to the limit your hand is going is your forward grip reach. About the forward fingertip reach, you can see this particular figure in which person is stretching along with his fingers. So stretching of the hands along with the fingers. So at the tip of the fingers to the point where your hand has been initiated. So this particular distance is known as forward fingertip reach. 14 is the sitting height. So about the sitting height, the sitting height is number 14, and it is defined as the vertical distance from seat to the top of head. So normally we use the 99th percentile of the male. I will describe this how we will find out this percentile and all, just for the sake of your knowledge. we use 99 percentile male sitting height to specify minimum overhead clearance. And in fact, we allow to about around 20 millimeter if hard hats are worn. So, in fact, since his person is not wearing hat, so we are not giving anything. So, as a allowance, so 99th percentile male sitting height to specify minimum overhead clearance. So, again this 15th is sitting eye height. So, that sitting eye height gives the center, this sitting height gives the center of the visual field of a seated worker and maximum height of a visual display. So, generally this 14 part we need to see what is that sitting eye height. So, in this sitting eye height, so again it is the distance from the inner eye corner to the seat, to the portion of the seat. So, this particular distance is known as sitting eye height. And as far as sitting shoulder height is concerned, so again it is the shoulder, it is the distance from the center of rotation of upper limb from seat. So, that is known as sitting shoulder height. Okay. And now sitting elbow height. Sitting elbow height is the seat surface to the underside of the elbow. So, you can see from this like sitting elbow height, it is 17. So, sitting elbow height is 17. So, this particular distance is known as sitting elbow height. The next kind of height is knee height. So, knee height is number 18 and 18 is showing here. So, 18 number is showing knee height, which is the distance from the floor to the top of the knee. So, this is the top of the knee and this distance is known as knee height. Third is buttock knee length. So, buttock knee length is denoted as a 19th. So, this 19 particular is the buttock knee length. It has been described as a horizontal distance from the wall to the front of the knee. This is front of the knee. So, and again this buttock popliteal length. So, buttock popliteal length is the horizontal, popliteal is basically the lower portion of the of your leg. So, that is the horizontal distance from the wall to the underside of the knee. So, this is particular let us say this particular portion is the underside of the knee. So, underside of the knee. So, this horizontal distance from walls to underside of the knee is known as buttock popliteal length. Again this chest depth is this is the sorry. So, this is as this is a chest depth basically, and as you can see from this figure also, 22 is the shoulder breadth, 22 is the shoulder breadth, and this shoulder breadth is defined as the horizontal distance between the right and left outer upper points of the shoulder blades. 23 is the hip breadth. 23 is the hip breadth. So, this breadth is known as hip breadth. 24 is the upper arm length. So, 24 is the upper arm length. As you can see from the upper portion to the knee, this is known as upper arm length. 25 is the forearm hand length. So, the forearm hand length is known as this particular distance, as you can see from this figure also. 26 is the hand length. 26, if you are just taking your fingers to the fingers and that particular hand portion. So, the overall hand length you can see that topmost corner to the, in fact you can say as a definition of head length, in fact as a top distance from the topmost point of the lengthiest finger to the point where your hand is started. In fact, this particular portion is started. So, this is hand length. Hand breadth is again width wise, if you are measuring, if you have to forget about your thumb, just for the fingers breadth you have to take, and that is that will be considered as a hand breadth. 28 is the grip diameter. The grip diameter, if you are firmly holding something, so at max how much diameter you can hold, that is your grip diameter, that is calculated as an insight dia. And as far as foot length and foot breadth is concerned, so in the lengthwise if you are taking, it is length and this is breadth. So, overall, so those dimensions, and basically these are the static, you can say the static anthropometric measurements commonly used in ergonomics. So, that is very much important in order to predict the mean and standard deviation of various parts in a variety of population. So, that is the chart that we need to become aware of what are the possible lengths and heights which can exist for the various posture of human being. Now, after having the knowledge of various static anthropometric measurement, we have to now see that how we can utilize this anthropometric data. So, there are basically two consideration here in this anthropometric data. First is based on the minimum dimension, and second is based on the maximum dimension. So, a high percentile value of an appropriate anthropometric dimension is chosen. So, let us have an example of a doorway. So, everybody is sitting on a room, and that room is having a doorway. So, suppose if you have been given a task to design a doorway, so what could be the possible measurement and what could be the possible criteria that you need to take care. So, the first kind of thing that you need to take care is sufficient headroom for very tall people has to be provided, and 95 to 99 percentile stature could be used to specify the minimum height. The important point is the doorway should not be lower than this minimum value. And in fact, the doorway should not be lower than this minimum value, and additional allowance also would have to be made for the increase in the stature caused by the items of clothing such as heels of the shoes, protective headgear, so on and so forth. So, as an example, you can also take if you are going to describe this minimum dimension case, that seat breadth is also determined with the help of using a minimum dimension. So, the width of a seat must be no narrower than the largest hip width in the target population. So, minimum dimensions are used to specify the placement of controls on machines, door handles, etc. So, the control must be sufficiently high off the ground, so that tall operator can reach them without stooping. So, in this way, so we describe the percentile, which kind of percentile we have to choose in order to come for the final design. So, we will take that the calculation of percentile and how we can perform the calculations in the forthcoming slides. So, second case is choosing the maximum dimensions. So, in that case a lower percentile is chosen as in determining the maximum height of a door latch, so that the smallest adult in a population will be able to reach it. So, the latch, door latch that we are talking about, so that door latch must be no higher than the maximum vertical grip reach of a small person. So, height of a non adjustable seats used in for example, public transport systems and auditoria is also determined using this principle. So, the seat must be low enough, seat must be low enough so that short person can rest the feet on the floor when using it. So, thus the seat height must be no higher than the first or fifth popliteal height in the population. So, so the anthropometric data must always be used in a cautious manner and with the sound appreciation of the design requirements and the practical consideration. So, in particular, designer should try to predict the consequences of a mismatch, like how serious they would be and how would be affected. So, the most important point is designer, or in fact an ergonomist, should try to predict the consequences of mismatch. So, in this way this designer or ergonomics plays a very important role and in giving a system comfortable comfortable in order to use it in a comfortable position, or in order to use it for a maximum users with a greater satisfaction. So, some of the examples that I have put in the slides, you can have it. So, there are some examples of some minimum dimensions, like the two things we have discussed before, that minimum dimensions and maximum dimension. So, in the minimum dimensions, the height of the doorway must be no lower than the stature of a tall man. So, you can see that the height of the doorway, in fact this is complete height, it should be no lower than the stature of a tall man. B is the width of the chair, this is the width of the chair must be no narrower than the breadth of a human being. C, a toothbrush must be long enough to reach the back molars of someone with a deep mouth. Then example for the minimum dimension is a door handle must not be lower than the highest standing knuckle height of the population of users. E is an example of the length of a wheel brace must provide sufficient leverage for a weak person to generate sufficient torque to loosen the wheel nuts. So, these are the possible examples through which, and this particular thing you have to take care in mind, that the height of it should be in a proportionate to the proper width of the, this is basically the lowermost portion of the rotating wheelchair. So, that is that height should be optimized in order to have a proper balance of that particular chair. So, these are the all the aspects, these are for example live examples which you can which you face while going through the daily activities or daily basis phases. So, you can pick up those examples from your surrounding also, and you can correlate with the ergonomic course also, because the ergonomics is all about enhancing the system's performance or the product performance, and products are in your surrounding. So, you need to open your eyes in terms of identifying the objects and analyze the objects in the form of its efficiency and how much you can contribute towards adding some of the points through which its efficiency can be enhanced. So, another the criteria of like some maximum allowable dimensions. So, the one of the kind of example is door lock must not be no higher than the maximum vertical reach of the small person. So, if this is like a door and the door lock is generally put at the topmost corner of the door. So, that door lock must not be no higher than the maximum vertical reach of the small person. So, think of a small person and think of its vertical height, and it should be that door lock should be attached at certain height, at that particular height, so that a smallest person can also reach at that particular point. So, that is the maximum allowable dimension you have to give it to the door lock. Second kind of example is seat heights. So, the depth must not exceed the popliteal height and the lower portion to knee lengths of small users. So, these two heights you have to take care in order to design a particular chair. The option all of you have must have seen this container, and so screw top lids must be wide enough to provide a large contact area with the skin of hand to provide adequate friction. So, also they must not exceed the grip diameter of a small person though. So, the products in your surroundings you have to identify, and in order to have a better understanding of this course, you can pick up any product in your surrounding and you can correlate with the theory that we are learning here. What are the products that can be fit into this minimum dimensional allowances and maximum allowable dimensions. So, now coming to the next topic, that is application of anthropometry in design. So, these are the design adjustable products fit for use surveys, anthropometric and personal space, workstation design and reach, and make different sizes. So, we will go in detail of these aspects, and just for the sake of one sentence that I have taken from some of the reference, that Ashby in 1979 illustrated the extent of anthropometric variability as follows. So, it is a very interesting statement. Please notify that if a piece of equipment was designed to fit 90% of the male population, it would fit roughly 90% of the Germans, 80% of the Frenchmen, and 65% of the Italians, 45% of the Japanese, and 25% of the Thais, and 10% of the Vietnamese. Basically, a 10th male per person of the US. This is the US population. So, it is missing here. So, I am adding that. So, if a piece of equipment was designed to fit 90% of the male population of the US, it would fit roughly 90% of the Germans, 80% of the Frenchmen, and 65% of the Italians, 45% of the Japanese, and 25% of the Thais, and 10% of the Vietnamese. That is a very interesting fact that has come out, and that has been predicted by this Ashby in 1979. So, thank you very much. Up to this we have covered this anthropometric human centered design we have discussed, and anthropometry we have discussed. So, in the next lecture we will be discussing about some of the statistics essentials which are necessary for anthropometric calculations, and some of the numericals we will try to solve, and till then goodbye.